Gentlemen, welcome back to the shop. Choking on my tongue tangulation here. We did an easy one for the first town pump project. Very happy with the way it turned out. Beautiful. Buddy Gnu suggested that we build a planchette for his barbecue. Who the fuck am I to argue? This is a good one because it's easy. It's very simple geometry. No, Buddy Gnu ain't French guy cooks, nor is he Winter Graham, nor is he any other big name YouTuber. How fair is it if somebody asks who's got a whole bunch of subscribers, and then the subscribers put the thing down in the doobly-doo, and then there's a bias there. So we're trying to just have this as open as possible and on the merit of the idea, not on the merit of the amount of subscribers someone has. So in the lessons learned bin here, I'm glad I have done manual machining because, well, manual machining is kind of automagic in that when you get into a sticky situation and there's some screeching or something funny, you just back it off. You don't even think about it, you just back it off. This machine is too dumb to do that. So what ends up happening is a whole bunch of busted mills, and well, this is just a high-speed steel Chinesium. It's probably about 10 years old, so it's due, but this just got plumb wore out. This one, programming error. This fucking thing loves the decimal point. If you forget a decimal point in any of the movements, you're fucked. The other thing is, even though it'll drill like a hot damn, these high-speed steel drills, and these are good ones, they can't really handle too high a feed rate. So you got to be pretty dialed in, because as I said, this thing, too dumb to know any better. She'll send this right through the center of the universe. And I started off real aggressive just to see what she could do. And yeah, there's one. Another one busted. Another one buys a duster. You see here, it's not the tip what welded. Too high a feed rate and just burn. As for the work holding itself, in this case, just a quick job. I didn't want to move the 5-axis or the 3+2, the 2-axis, the A and the C. Didn't want to move the vise. No big deal. I put the protective condom over this thing because, you get a big stringer whipping around and it's lights out for that. It was reasonably rigid. That spindle speed variation saved us. So what that does is you set it so that it varies the speed over, say, 100 or 200 ripplings over the course of a second. So it's constantly speeding up and slowing down. That doesn't allow, it helps you to not set up a harmonic frequency in the workpiece itself. Recall, everything is a spring. Everything is a spring. So you want as rigid a structure as possible, but at the same time, it will resonate at a certain frequency. That spindle speed variation helps us out there. For the clamping of the workpiece, now we had to come up with some fancy dancy stuff because we were at the envelope, or the work envelope. One thing here, even though the Chinesium grade ready rods work just fine, if you're not straight up and down, clamping straight up and down, and you clamp it down, what ends up happening is the clamps pull the workpiece out of alignment. Well, just a slight curve to the left there, and you saw midway I was cutting along here, and it was all cattywampus. I had to replace this because it's got a wow in it. At the end of the day, we clean this off proper, give her some wiener sliding so as to not let her rust, and then put her to bed in the home position. Pain in the arse is getting all the chips out of these crevasses. We're going to go ahead and machine something to cover, and we'll tie into these fixture plates here. Mirror, mirror on the wall, what's the highest removal rate of all? A bandsaw. We didn't have a bandsaw on this here machine, so we drilled it out. That seemed to work okay. Took a lot of meat off right quick, fast, in a hurry. The thing is, because we're going down an inch, we only got but the 1/2-inch end mills hanging out, and they weeble wobble far too much chatter. So it's nice to get rid of a bunch of material right off the hop and then just come in with the end mill and lop it off. So that's what we did there. That seemed to work pretty good. Now for busted up tools, that 1/2-inch was a 1/2-inch twist drill. That was a tough one, and it was stuck in a blind hole. So I pecked at it with a carbide, I wasn't really liking the effect, so I decided, because it was a small hole and I was well within, you know, I had lots of meat there to take away, I went in with the roto broach here, the annular cutter, and just cut that slug right out and left the end of the high-speed steel tool in there and just cut it out. That seemed to work the best. Speeds and feeds, holy shit. It goes to the old adage, first you get good, then you get fast. So experience allows you to narrow down that speed and feed window to sort of where you think is going to work. But when you see these CNC machines just a fucking giving it, it's because they ran the program and optimized it over a couple iterations to get the perfect feeds and speeds. You ain't gonna hit it unless you're super lucky. You ain't gonna hit it right off the bat. So dial it back a little bit, get your feeds and speeds to where you're not chattering and screeching. And yeah, there's nothing for it but to prove the program, and also not only feeds and speeds, but you can optimize your moves as well. You can do a GOO instead of a linear move, just a regular feed move. You can do a fast rapid, in and out, all that sort of stuff. That's with the G code. Not really getting into that because I feel the G code, it's 50 years old, something like that. It's a false economy. Not to say I'm not learning G code. It is useful to see what's coming up and to do very simple maneuvers. But for instance, pocketing the planchette out, I used a G150. Now a G150 is a canned routine, but the problem is it goes into conventional milling and then into climb milling and into conventional milling and into climb milling. So it's really hard on your cutters. It's a false economy to use that G50 rather than model the part and do a tool path in your CAM software, because your CAM software can optimize for the perfect chip load with chip thinning and all that. You get a lot longer lifetime on your milling cutters that way. Now you saw I wanted that 1/2 or 3/8 step over. I wanted that to look all pretty, and it looks pretty because it's in a different direction. Climb milling, conventional milling. However, it is fucking hard on cutters, so that type of pattern costs money. Bunch of irons in the fire. We are not seriesing these projects up, we're paralleling them. So you might see one simple one get bumped ahead of the curve of a more in-depth one, such as, well, the one we're working on, which is a fantastic fucking idea, but he's got a prosthetic leg and it doesn't have a pivot on the ankle. So when he goes to sit down or he's climbing a hill or whatever, it's a pain right in the, well, probably in the stump. Son of a bitchin' thing, you can't change the angulation of the foot. So we are going to make a locking ankle for this fella. Also for Curious Mark, we're making that helical gear, well, that worm gear, essentially. It's multi-start, probably 10-start worm gear. We're making that. He's sending us the file, or no, he's sending us the actual part. We'll make a model and then machine it from there. If and you got any ideas, your 30-second video, just post it up. You don't got to do any kind of, just, this is the problem, this is the solution. That's it. Put it in the comments. We'll put it in a playlist, and then the ones that tickle my fancy, tickle our fancy, we'll go ahead and do. That's all there is to it. If and you're worried about, guys are wondering about patents and fucking IP and all that bullshit, partner, if you're worried about that, fucking give her. I ain't touching it. not touching it. This is stuff, non-commercial stuff. If you want to commercialize it later, that's your affair. I'm just machining it.